Hello students, welcome you to the course of Compiler Design. Today's lecture we will be studying about backpatching. This is a technique which is being used mainly for Boolean expressions to identify the flow of control in a Boolean expression. Wherever we are having Boolean expressions, how to follow the if condition, the true part and else false part, that is being done here. We were studying the three address code for given if expression. So we will recall it. Supposing we are given an if condition as if A less than B, then 1, else 0. We learned to write the three address code by using two passes. So in the first pass, we will just fill the go to conditions with blanks. So we don't know to which statement number we have to go. So we will simply write if A less than B, it is true. If the condition is true, we have to go somewhere. And the general understanding is the immediate statement will be the false condition. So here we can very well write the value else 0 condition is T1 equal to 0. Then whether it is true or false, we already learned while we were studying the syntax directed translation. Even if the condition is true or false, we have to continue with the remaining part of the program. So it has to go somewhere to the remaining part of the program. So if the condition is false, we will assign T1 to be 0 and we have to fill the statement number to continue the remaining code. And obviously the else part is completed. So now we can assign the true value. So T1 equal to 1 can be the fourth statement. So this will be the first pass. In the first pass we are giving blanks and we are trying to calculate the go-to labels. During the second pass, now the scenario is very clear to us. If the A less than B condition is true, I can straight away go to T1 equal to 1, which is nothing but the statement 4. So I can write off in the pass to go to 4. And similarly, after the false condition T1 equal to 0, I have to continue with the remaining part of the program, which is nothing but our statement 5. So in this particular go to blank, I can fill it with 5. So this is the method we followed while we were learning about the three address code. But there is another method by which we don't need to do this two passes. In a single pass, we will be able to fill the blank or this go to condition label. So we will see about this today. So same example with a illustration. Yet another example. All this we have already done. Just for recap, I put it here. So if it is two conditions, it is an AND condition. So both the conditions have to be followed. So we will initially put it as if A less than B, go to dash. And then if it is false, means it is an AND condition, we have to go to the false part. But there are two conditions. So we have to check both the conditions and only then assign the false condition T equal to 0. So if it is true, we have to check the second condition also. So we come to the third statement. After checking, we can then assign. If both the statements are true, then it will go to T equal to 1. And if it is false, it will be T equal to 0 and we have to continue with the remaining of the code. So backpatching allows us to do this entire operation in one pass. And generating branching statements with the targets of the jumps temporarily unspecified. That is what we did. The jump statements, go to statements, we had left it temporarily unspecified and later in the second pass we filled. But we are going to learn another method, backpatching, by which we can do it in a single pass. So backpatching is a way to implement Boolean expressions and flow of control in one pass. For this particular thing, the code is generated as a quadruple into an array. So we need three important functions, namely make list, merge of two pointers, and then we have the backpatch function. We will see all this in detail by taking an example. So we told that this is mainly used for Boolean expressions and control statements. Control statements are definitely going to have Boolean expressions. So we analyze the grammar for Boolean expressions. Here there is some addition in the grammar. Can you visualize which is the addition? Already we have seen the grammar for Boolean expressions. So here there is some additional information. So as you can see here, we are having E1 or E2. There is a M added here. Similarly for E1 and E2, we have added a M here. And M is defined to be a null production. So it doesn't make any change to the definition of the grammar or the production rule. Okay. So we need to calculate E1 or E2, E1 and E2 and so on. So we are introducing one very non-terminal M, but it is not going to alter the change the expression or the production because it is a null production. So this is nothing but a marker. M is a non-terminal which is a marker, and it is inserted into the grammar to pick up index of next quadruple. See, we need to know whether we have to evaluate, after evaluating E1, should we necessarily evaluate E2. So for that only we are putting the marker. And then we are going to talk about two important things. Something called true list and false list, which will act as attributes for this grammar. So we know very well that as we do the semantic analysis, we need the attributes. So here we are going to have a true list and a false list. See, we have to track whether the condition is true or false while evaluating the Boolean expression. So in order to do that, we are going to introduce two attributes, true list and false list. As we move on, we will understand this better. So we have the grammar E1 or E2, E1 and E2 and so on, all the grammar rules we saw. So we will evaluate one by one. We will analyze them. So first we will take the AND condition. In the AND condition, E1 and E2, so we already have the marker. Now it is an AND condition. So when E1 is true, I have to definitely evaluate whether E2 is also true. Because if E2 becomes false, the entire expression is going to be false. You can refer to the truth table. In your earlier classes, you must have studied earlier subjects. So if both are 0, AND operation is 0. If 1 is 0, again 0. Only the final operation, if both are 1, only then it is 1. So if both are true only, the answer is true. So all these four conditions we have to express in terms of statements for the compiler to understand. So it is a conversion of this truth table into proper statements. So when E1 is true, we have to definitely evaluate and find whether E2 is true or false. So whenever the second evaluation is required, we will call a function called backpatch. Okay, already one is true. So I need to go to the next quad, next operand and evaluate it. So that is why we are saying backpatch of true list comma M quad. M quad, we told that it is for the marker to indicate that we need to go to the next operand. Supposing any one of them is false, then you know very well the combination. If any one is false, all the first three conditions, definitely it is false. So we can easily assign off the false list as merging E1 false list and E2 false list. That is, either one of them is false means when I merge, the answer is going to be false. And when E2 is checked and E1 is already found to be true, then we have this last condition. Both are true. In that case, because already E1 is true, the condition of E2 is now determining the true value. So we are putting E dot true list to be the E2 dot true list. Okay, so this truth table you already know. The same truth table we are expressing in forms of statements, because this only can be converted as the grammar for the compiler to understand. It is not going to understand the truth table. So we are conditioning it as statements. We'll come to the OR condition. In OR condition, if 1 is false, then we have to definitely look into the second part, because if the second part is true, then we can make it as the answer is true. So it will be backpatch of that false list. Already we know that this is false. Now we are going to check the next quad information. So we are saying backpatch of false list. Now if any one is true, we know very well from the truth table, if any one of them is true, answer is going to be true. Okay, so that condition is the true list. We are merging T1 true list and T2 true list. So if any one of them is true, the value will be true. The last condition, that is both are false. If both are false, so E2 we checked and then we found it false, E1 is also false, then means already this is false. So the second one also we have to check, only then we can make it as false. So the false list will now depend on E2 dot false list. Please refer with the truth table. Only three things. We have to either do backpatch, or we have to merge, or we have to simply assign the true list or false list. For OR condition, we will be assigning the false list. For AND condition, we will be assigning the true list. So both are the opposite of each other, OR and AND. So accordingly, the conditions will be varying. Now the remaining productions, see I am checking one by one the grammar rules, what was given for the Boolean expression. So the third rule is E arrow not E, which is just the reverse. So if it is true, E1 will be false list. If it is false, E1 will be true list. And assignment is the same. So if this is true, this is also true. If this is false, this is also false. So not much change. Now coming to the final rule, we have this if condition. So if ID1 relational operator ID2. Okay. So for this, what we have to do is we have to refer to the 3 address code we already studied. So what will we do? We have to give statement numbers. That is why true list is 1. Okay, next quad. Then false list. The next statement is next number. So next quad plus 1. Okay, this is 1, so this has become 2. Then we have to emit the statement. We are writing if A less than B, go to dash. And then in the next statement, we will say go to dash. Okay, so these are the statements what we already learned to write in the 3 address code. And similarly, if it is true, we have to make the list and go to the condition true. That is why we are saying make list of next quad, and then we have to emit this go to. So this go to what we are writing now, that is being expressed like this. And we know very well that this is a null production. So M quad means the next number. That's all. So with this understanding, we can frame the set of rules for backpatching. So I've written down whatever so far we discussed, everything I've summarized and written here. So for doing backpatching, this will be a analytical question. They will be asking you to find out the values or the solution by using backpatching method. So these are the rules that we will be following. So if it is an OR operation, the true false list will be the backpatch and true list will be the merge function, and then the false list will be equal to the false list. Okay, and if it is AND operation, backpatch will be with the relation to the true list and mquad, true list will be the true list, and false list will be the merge of false list. So the remaining all we already saw, and this also I just now discussed. So everything we have summarized and we have all the rules. So now using these rules, I will be able to easily write the labels, how to generate the labels. So the question will be generate code for x less than 100 or y greater than 200 and x not equal to y. So three different Boolean expressions are there. We have a OR operation and a AND operation. So it is very clear that supposing this is true, okay, if the first condition is true, it is the OR operation. So we don't need to bother about what is in the next thing. So that's how we learnt in that backpatching algorithm, no? If it is OR operation, then we very well know that you don't need to bother about this, because if any one is 1, we learnt in the rule that if one of them is 1, true list of this is true list of this. Okay, so we can straight away go evaluate the true list for this condition. We don't need to evaluate this part at all. Whereas in the previous operation, we will have to do this. We have to go ahead and do every statement and only then we will find. But here, because of the backpatching rule, because it is an OR operation, you don't need to go here. Okay. In case this is false, then we have to find out whether this is also false or if it is true. If it is true means then we have to do the true condition. So we will go ahead and evaluate. So that is how the condition is. So I'm simply writing the single pass. If I'm going to do, how am I going to do? That's what I've written here. So if the condition is true, I don't know. So like that I'm writing for everything. Okay. And then we will try to solve it by using the backpatching method. For the backpatching method, we will draw a parse tree. How do I draw the parse tree? Okay, the expression given was x less than 100 or y greater than 200 and x not equal to y. That is the condition given. The AND operation is here. So we are drawing it as a normally how we draw an expression tree. So we know that x operator id1, operator id2. Okay, and this is my OR operation, and we have to now include this m. We know that the production has been modified as, so let's say you assume it here as E. Okay, so E arrow E1 or E2. Okay, so here it is given as B. So B arrow B1 or B2, we will be having the M quad. So B arrow B1 or M B2. Similarly, if I come here, it is an AND operation. So it will be B2 arrow, again this B1 and M B2. Okay, so that is what we have drawn the tree as, based on the production there. B arrow B1 or B2 or B arrow B1 and B2. So now we have to start with the formulas I showed you, know, from there we are taking. Initially the true list is some number, so I am putting it as 100, and false list is next of that. Okay, added. So while writing the 3 address code, we wrote down, no, statement number 1, 2, 3. Like that I've taken it as 100. Okay, so the second statement number will be 101. Now I have to come to M quad. I'm coming here. I'm going to travel like this. So I'll take the next number. So M quad will be, in that rule also it was there. M dot quad will be M quad plus 1. So 101 plus 1, 102. Then next we have to come here to this leftmost branch. Since it is a null production, we can use the same 102 here for the true list. And then the false list will be 103. Okay, we are adding 1. Then we travel here, M code is 104. But again, this is a null production. So we will use the same value here for the true list, 104. And then the false list is 105. Now we have to evaluate this. This is the AND operation and take it up. Okay. So when you come up for the AND operation, what is the true value? The true list is equal to the true list of B2. That is the rule. You can refer later. So whatever is here, we have to write it here. That is 104. And false list is merge of B1 dot false list and B2 dot false list. So we are adding both 103 and 105. So this is for the AND operation. Now we have come to the OR operation. When I come to the OR operation, the T1 true list is merge of B1 true list and B2 true list. So we are getting 100, 104. And false list is equal to the false list of B2. So that is 103, 105. Okay. So this is how all the labels I am able to fill. So using the filled labels, I can directly write the missing values. So that is the understanding of going for backpatching method. In the original method, we were actually putting blanks, and then in the second pass, we were filling the blanks. But here, we don't need to do that. We can find the blanks with the backpatching method. So whatever values are available here. So this will be forming the statements. And accordingly, we can write the statement. So finally, the answer will be like already we anticipated. So if the condition is true, then we don't need to evaluate the AND part at all. Straight away I can go off to 106 for the true value. Else I have to check the condition. So I am going to 102. In 102 I am evaluating. This is an AND operation. So both the conditions have to be evaluated. So y greater than 200 is evaluated. Then we have to go to the x not equal to y condition. Both are true means then we have to go to the true. Any one is false, it is an AND operation, so we can come to the false condition. So it is much easier to use backpatching to find the unspecified labels while working with control statements, which obviously have Boolean expressions. Thank you.